Welcome to our lesson on electric fields around point charges. An electric field is a volume of space where a charged particle will experience a force. An electric field exists A, around a point charge, or B, between two charged parallel plates. Around a positive point charge, the electric field radiates outward because that is the direction a positive test charge would move if placed in that field. This is an arbitrary choice. We have chosen to use a positive test charge. This is universal. A positive test charge will move away from a positive charge. So the direction of the electric field is said to be outward. Around a negative point, the electric field radiates inward because that is the direction a positive test charge would move if placed in that field. So a positive will move towards the negative it is attracted. So around a negative charge, the electric field radiates inward. As with Coulomb's law, the electric field strength E is proportional to the size of the charge producing the field. So that would be this charge is producing the field. That's the charge that is proportional to the electric field. The size of the charge being influenced, Q2, which would be the test charge, does not affect the field strength. Just as you and I, because of our mass, do not affect the gravitational field that we are in. The charge being influenced, Q2, receives a force per unit of charge, and so experiences a larger push or pull if it has a larger charge. But the field strength is not changed. This is similar to the way the Earth's gravitational field affects your weight. The more mass you have, the more weight you feel or force of gravity. However, your mass does not affect the Earth's gravitational field of 9.81. As with Coulomb's law, the electric field strength E is inversely proportional to the square of the distance from the charge producing the field. E is proportional to 1 over r squared. Finally, the equation for electric field strength can be determined, since it is the same result as taking Coulomb's law and dividing it by Q2, or the test charge. So E is equal to F over Q. Notice the units of the electric field strength are newtons per coulomb. If we take the equation E is equal to K Q1 over R squared, the units for K are Newton meter squared per coulomb squared. If we multiply that by coulombs and divide by meters squared for R squared, notice that the meters squared on top are cancelled by the meters squared on the bottom. Then one of the coulombs in the coulomb squared in the denominator at the top are cancelled by the coulombs of Q1. All we're left with is newtons per coulomb. At this point, you should review a number of problems and applications requiring this new equation to find a solution.